Hello students, today we are going to see the cylindrical coordinate system. So cylindrical coordinate system is also an orthogonal coordinate system. It has three axes and the axes are rho, phi and z. Here the rho varies from 0 to infinity. Rho is nothing but the radius of this. You can see in this figure. Here rho is represented as the radius of the cylinder. It is actually the cylinder is shown for a single quadrant. You can see for the four quadrants. So rho, it is the radius of the cylinder. The radius can extend from 0 to infinity. And second parameter is the pi, which is the angle. It varies from 0 to 2 pi. So angle means, so in this you can see here at the from the axis, from the center point of the cylinder, this angle can vary from 0 to 180 degree. If it is 90 degree, it is only a sector. If it is 180 degree, it is a semicircle. If it is 360 degree, then you can get a complete cylinder. So angle can vary from 0 to 2 pi, and z is the height of the cylinder. It can vary from minus z axis to plus z axis, or otherwise I can say it is from minus infinity to plus infinity. So like in the similar to the coordinate system, Cartesian coordinate system, equation can be written for cylindrical coordinate also. So the corresponding vectors are a rho, unit vector a rho, plus a pi, unit vector a pi, plus a z, unit vector a z. Small here small vectors a rho, a pi and a z are unit vectors acting in the rho, pi and z direction. And likewise the magnitude also found out by using the equation square root of a rho square plus a pi square plus a z square. So as it is an orthogonal system, the angle between rho axis and pi axis will be 90 degree, and pi and z will be 90 degree, and z and pi equal to 90 degree. So we can implement this condition for the dot product and cross product. For dot product, since it is 90 degree, the same dot product a rho dot a rho equal to a pi is equal to dot a pi, and a z dot a z. All these the dot product will be equal to 1, and a rho dot the other axis a pi or a z. If you do the dot product, you get the 0 because the angle between them is 90 degree. Cos 90 will be 0, so you get a dot product as 0. And for the cross product, a rho into pi will be a, like I cross j equal to k. Likewise, you can get these Cartesian products. So you can see a video related to cylindrical coordinate system in a 3D animation for better understanding. You can see here in this diagram, this is the usual Cartesian coordinate system. There we are going to embody a cylinder. So the top surface and bottom surface will be a circle. So likewise you can see many circles or many discs are arranged one by one above the other. We can get a cylinder. For each disc, the radius will be radius can for each circle or disc radius can vary from 0 to infinity, plus infinity. You cannot have a minus infinity radius. You can have up to plus infinity. So constant R surface, the outer surface, that is the lateral surface, will have constant R. See the circle. This is constant pi surface. Here the pi is the angle between the x-axis and this plane. So you can see here there is an angle. This angle, if it is coincide along x-axis, the angle will be 0. If it is coincide along y-axis, the angle between x and y will be 90. If it is going to coincide along minus x-axis, then the angle will be 180 degree. Likewise, the total angle will be at 360 degree. And along this plane, which value is constant? Pi value will be constant. For this also pi, same thing. This also pi, same thing. For this, along this complete plane, the pi will be a constant. So first one r constant, you can see here. This one is a constant, is a surface plane. The top and bottom portion, it will be in the form of circle, but for better understanding I have shown here. So it is a surface. This constant is a surface that go up to minus infinity to plus infinity. So if you see in a plane, this cylindrical coordinate system consists of three planes. One is that blue color has constant is a surface, which is going to appear in the center portions, top to bottom. It is a plane. This plane has constant angle. This angle going to vary from 0 to 360 degree, and this is a cylinder, and this cylinder has constant, or the outer surface of constant r, but r can vary from 0 to plus infinity. So any point in these cylindrical coordinates can be represented using three parameters, rho, pi and ez. So here the point P is located and rho is the radius. So rho represents the radius, means from the axis how much radius. So if only one, this alone is known, means this point P can be located from this point to this point along the same circle. So it's not at all enough. So we go for another one parameter, pi. We have to take pi angle. The intersection of these two will be a point of P. If we look for intersection, we can have the point P can be located from this point to up to this point, which has so many. If it is R, the complete green color has that position. So if we take pi also into account, then P can vary from this point to up to this point, up to minus infinity to plus infinity. So we go for the next one, Z. So now you have height, know the height from the bottom surface, you take the height Z. So the intersection of 3 points will be this one. See here, this one. So the point P is located like this. So we need the three parameters for the exact location of the point P. So like we have three unit vectors. I already said A rho is along x-axis and A pi along pi axis and A is along z axis. We have to calculate the differential volume and differential area. So differential volume is given by, see here, a small volume. In cylinder we are going to take a small thing, and this will be dz because it is the height dz, and it is the radius, the small radius d rho. So this one dz, see here, this one dz and this one d rho. What about this one? So we have to go for s into r theta. It's a set r, s equal to r theta. Here r is rho and theta is the small angle d pi. So this value will be rho into d pi. So if you want the volume, just multiply all these three quantities, we can get the differential volume. So rho into d pi, d rho into dz. You can get the volume. The product of all these three parameters will give the volume. If you want to get the differential area, for this surface, this is dz and this one is the rho d pi. So differential area of this surface and opposite and diagonally opposite face will be rho d pi into dz. For this portion, it is d rho and this one dz. So d rho into dz for this face and diagonally opposite face. And for the top and bottom portion, the area will be rho into d pi into d rho. So now we are going to see how to convert a cylindrical coordinate system into Cartesian coordinate system, because some problems which we find it difficult in Cartesian coordinate system can be easily solved in the cylindrical coordinate system. So you must know the transformation or the relationship between these two coordinate system. So if you know the cylindrical coordinate system, that is rho pi z, you can calculate the Cartesian coordinate system x equal to rho into cos pi, y is equal to rho into sin pi, and the z value remains the same. And likewise, if you know the Cartesian coordinate system, you can find out the cylindrical coordinate system by using the relationship rho equal to square root of x square plus y square, pi is equal to tan inverse of y by x, and z equal to z. So how to find out the this is the relationship is for point transformation. How to calculate for the vector transformation? So vector transformation, if you know the components of vector in Cartesian coordinates, you can easily calculate for this coordinates. So a rho equal to ax cos pi and ay sin. How to calculate ax ay is taken from vector. How to calculate cos pi and sin pi? Use this relationship. If you calculate pi, you can easily find out cos pi and sin. Likewise, a pi equal to minus ax sin pi, ay cos pi, and a is equal to ax. If you know the cylindrical coordinate component, that is components, then you can calculate the ax, ay, and az. So the total vector in Cartesian system can be obtained by a is equal to just here you can add these values. So here if you take if you add all these things, you get a rho common, you get cos pi plus sin pi. So ax cos pi, because it is for x component, a capital ax cos pi plus ay sin pi the arrow. For this component pi minus sin pi and plus cos pi. So minus cos pi sin pi plus cos. This one, sorry, it is a mistake. A minus ax sin pi plus ay cos pi. A pi is taken common and it is a z only. So a z into a z. So same relationship is written here also. We are from this we are going to write the transformation vector. So in otherwise you can say this bracket as a rho and this bracket as a pi and this one as a z. So a rho a pi a z equal to cos pi sin pi 0. So you can easily find out. Actually, this you can easily find out. And you can easily find out from this vector equation. So here you can say, you can find out. Here you can see here, if you multiply ax into cos pi, are you getting this one? Ay into sin pi, are you getting this one? Plus 0. So this one, the first component comes. So first component vector will be a rho, because we are going to write in the cylindrical coordinates. For second equation, minus sin pi into ax, the first component, plus cos pi into ay, the second component, and then 0. So it's not written here. Here 0, 0, plus then you get a z alone. So a z, the corresponding unit vector will be a z. So like you can transform the x component vector into cylindrical coordinate vector easily using this matrix multiplication. If you want to have the inverse transformation, if you know the cylindrical coordinates and you want to calculate for the Cartesian coordinates, just take the inverse of this one. If you take the inverse of this matrix, you will get cos pi minus sin pi 0, sin pi cos pi 0, and 0, 0, 1. So you can easily calculate this. If you are able to write down this transformation vector, then it will be quite easy to have the inverse transformation. So from this we finished the cylindrical coordinate system. If you have any doubt, you can ask us. So in the next class, we let us see the spherical coordinate system in detail. Thank you.